From your email inbox to your favorite streaming service, machine learning is pretty much everywhere. It's one of the most transformative technologies of our time, for sure. But how does it actually work? Well, let's dive in and pull back the curtain on how computers are learning to think. So it all really boils down to this one huge question. Can a computer learn without us having to code every single step? The answer is a massive yes. And, well, that's what changes everything. All right, first up, let's get a handle on what we're actually talking about. What is machine learning? To get it, you've got to move past the idea that computers are just big, dumb calculators that only follow instructions. Okay, so here's the textbook definition, but let's make it simple. Machine learning, or ML, is a part of AI where we don't write the rules. Nope. Instead, we just feed an algorithm a ton of data, and it figures out the rules all by itself. That phrase right there, learn from data, that's the real secret sauce. Think about it like this. Old school programming is super rigid, right? You'd have to write a rule. If you see this exact octagon shape, and it's red, and has these white letters, then stop. But with machine learning, you just show a self-driving car thousands of pictures of stop signs. In the rain, at night, half covered by a tree, and it just learns the idea of a stop sign. It's way more flexible. So just to be clear where ML fits into the whole picture, if artificial intelligence is the big goal, making smart machines, then machine learning is one of the most powerful ways we're actually making that happen. It's a key tool in the AI toolkit. So if we're saying machines learn, what does that actually look like? Well, it turns out there are three main ways they do it, three learning styles. And honestly, they're probably going to sound pretty familiar to you. Okay, so here are the three big ones. First, you've got supervised learning. That's like studying for a test with an answer key. You have all the examples and all the right answers. Then there's unsupervised learning. Think of that like being told to organize a super messy closet without any instructions. You just have to find the patterns yourself. And finally, reinforcement learning, which is basically just training a dog. You give it treats for good behavior, a reward, to encourage it to do the right thing. Now, I know this all might sound a little abstract, but I promise you, you are interacting with all three of these learning styles all the time. Let's look at some examples you are absolutely going to recognize. Let's start with your spam filter. It's gotten crazy good at catching junk, right? But have you ever stopped to wonder how it just knows what's junk and what's not? Yep, that's supervised learning in action. The algorithm was taught by being shown millions and millions of emails that people, actual humans, had already marked as either spam or not spam. It learned all the little patterns of what junk mail looks like, so now it can spot it instantly. Okay, how about this one? Your streaming service suggests a new show, and it is weirdly, perfectly what you were in the mood for. That's not a lucky guess. That's another type of ML. This is the magic of unsupervised learning. The system doesn't know why you like sci-fi shows with strong female leads, it just knows that you do. It analyzes millions of users and finds little groups, or clusters, of people with similar tastes. It sees that people in your cluster also loved this other show, so it figures, hey, you probably will too. And for our last example, let's jump into gaming. You ever play against an AI opponent that just seems to learn your every move? It adapts to what you're doing and gets tougher and tougher to beat. That's reinforcement learning. The AI has one goal: win the game. Every move it makes that brings it closer to winning gives it a little reward point. Every move that leads to losing is a penalty. So after playing millions of games against itself, it just learns through pure trial and error which moves get it the most rewards. So this all sounds pretty incredible, and it is. But this learning process isn't perfect, not by a long shot. And it comes with some really big challenges we absolutely have to talk about. One of the biggest problems is what experts call the black box problem. Basically, sometimes these systems get so complex that even the people who designed them can't fully explain why it made a specific decision. It gives us an answer, but we can't always see the why behind it. It's just opaque. And that black box can hide a really serious issue: algorithmic bias. See, if the data we use to train the machine has our own human biases baked into it, the machine is going to learn those biases too. And this isn't just a theory. We've seen it happen. A hiring tool that learned to discriminate against women because it was trained on a company's past biased hiring data. Image recognition that didn't work well for people of color because the training photos were not diverse. The AI isn't evil. It's just a mirror,
reflecting the patterns we show it, including the ugly ones.
And that brings us to the most important takeaway of all. A machine learning model is only ever as good and only ever as fair as the data we give it. It all comes down to the data. Garbage in, garbage out. Or more accurately, bias in, bias out. So this leaves us with a really tough question to chew on. If a machine is learning from the world we've created, does that mean it's also learning and even amplifying our worst flaws? Are we in danger of building our own prejudices into the automated systems that will shape our future? That's the real challenge we have to face.